Here we go. Okay, so I posted a poll on Moodle to see if you guys wanted to have a third test or if you were just done with tests and you want to just have the final exam. Last time I checked, it was kind of a 50-50 split. So that poll is going to be open until midnight. So make sure that if you haven't answered already, then maybe give me an answer before midnight tonight.
You said on Moodle?
It's on Moodle, yeah.
Under math.
Sorry, say that again?
Under math?
Yeah. It's in the bottom week 12 section.
Oh.
So.
December 3rd. When's the final?
Our final is.
Do we have a date yet?
Yes.
It's on 12.
It's on the 12th, right? Yeah. 1:30 to 4:30.
And it's all of the chapters?
It is. So the final exam. Now, yeah, because I'm not used to this this tablet, I keep leaning on the bottom buttons. And so it shoots up the keyboard, it shoots up the calendar. I'm trying to not touch it, but it's really hard. Our final exam is on December 12th. 1:30 to 4:30. Oops, not sure. That. Okay. So 1:30 p.m. to 4:30. It's on a Saturday. Okay, sorry, I know people get confused. 1:30 p.m. to 4:30 p.m. When I use the 24-hour clock, people don't like that.
Nope.
But I like it because it makes more sense. But anyways. So it's on December 12th, which is actually a Saturday. On Saturdays, I'm not sure if you've had final exams at the college before, but even at UBCO on Saturdays, they bump them back by half an hour. So the start times are a half hour later. Whereas usually the exam blocks are 9 to 12, 1 to 4, and then 6 to 9. I think it's 6 to 9. Anyways, I can't remember. It's been so long.
So it will start at 1 to 4 or 1:30 to 4:30 then?
1:30 to 4:30 for us.
On WebAssign, right?
Yeah. We're actually talking about it as a group. So everyone who's teaching this course, we're just kind of figuring out what we want to do. If we want to do kind of a mix of WebAssign or and some written work, or if we just want to do WebAssign. But yeah, it'll be very similar to what we've been doing so far for tests. So I posted a poll.
I just answered it.
Nice.
Yep.
I'll just make a note for everyone who's not here, which is a lot of people. So I posted a poll on Moodle, due at midnight tonight.
It's like the more tests one?
Yeah. So it's just to see if you guys want to have 3 tests, or if you're done with tests and you feel good. It's really just if you want an opportunity to kind of even out your grades, then maybe a 3rd test is a good way to do that. But I know you're probably really tired at this point in the term, so I don't want to force you to have a test. So that's why I'm asking everyone what they want to do. But we're just going to do whatever the majority vote is. That's what we'll do.
I also answered that.
Are you able to see what the responses are so far? I haven't checked in a bit.
Check.
Nope.
No.
No? Okay. Maybe I missed putting that on.
Yeah, I can see that. 60%
For which one?
is yes for test.
Everyone
And
wants a
40%
test. Well,
is
not
no.
everyone.
Like 10 people have responded.
Okay.
Yeah.
14 or 15?
I think there's 13 in the class. So we would need, like, 7 votes would be the majority if everyone voted. But I'll just finish writing here. Your vote is anonymous. The majority decides, right? So whatever gets the most votes is what we'll do. All right. So, so you guys have already answered it, but so that's awesome. Hopefully you get what you wanted. Okay, so last day we finished, we did, what did we do last day? Oh yeah, exponents and logs. So exponential and logarithmic functions. We actually finished that section. So we're not gonna go back. I'm not gonna do a review because we don't actually need it today. And so, but make sure that you go back and review it on your own time. So today we will start trigonometry. Oops. Trigonometry. Or trig. Got a little thing I want to get rid of there. Okay. So we're going to start trigonometry, and which is chapters 5, 6, and 7. I've actually decided that we don't need to do chapter 7, so I'm cutting it. That's after talking to other people who are teaching the course, and they're like, oh no, 5 and 6, that's fine. So I'm like, okay, well, let's not do 7. So we'll do chapters 5, 6, and 7, but we're just kind of, we'll cut chapter 7. Okay. So in general, so trig is things like SOHCAHTOA, sine, cosine, tangent. But in order to get there, we need to establish there are 2 key methodologies for working with trig. And so there are 2 approaches to solving trigonometric problems. Okay. So the first one is with the unit circle approach. Unit circle approach, which is what we'll start with. And then the second is the special triangle approach. Okay. Depending on the problem that we're solving, one of these it might be easier to use than the other. So that's why we need to introduce them both. Okay. So we introduce both methods, because one approach may be easier or just kind of quicker or whatever, right? So because one approach might be better / easier depending on the problem. Depending on the problem. So that's what we'll find, right? So we'll start with the unit circle approach. So we're going to talk a lot about the unit circle and just kind of what some common points are on there. And then we'll kind of start all over again in chapter 6 with the special triangle approach. So the unit circle approach is in chapter 5, and then the special triangle approach is in chapter 6. So what's going to happen is we'll introduce both approaches, and then we'll kind of go off in chapter 5. We'll just do 5.1, 2, and 3. And then in 6, we're going to do 6.1, 6.2, and 6.4. So we kind of branch off a little bit. Give me just a second. Oh, I'm calling to Jared, but he's in the garage, I guess. Anyways. Okay, so we're going to introduce both methods. We'll focus on the unit circle approach for this first part, which means we have to talk about the unit circle. That's our dog. She likes yelling at people on the streets. There's no one out there right now, though. She's just mad. Okay, so we'll start with the unit circle approach. So 5.1 is on the unit circle. So we're just going to talk about just different aspects that we need to know about the unit circle. Okay. I think I picked the paper with the lines are too close together. So I'm trying to stay on the lines, but it's hard. The unit circle. The unit circle is the circle of radius 1, okay, centered at the origin of the xy plane. Centered at the origin of the xy plane. Okay. Its equation, we'll need to know, is x squared plus y squared equals 1. Okay. In general, a circle, we haven't really talked about, or we haven't talked about it at all actually, is x squared plus y squared equals r squared. But because we're on the unit circle, the radius is 1. 1 squared is 1. Right. So the radius is 1, so that's why we have this x squared plus y squared equals 1. Now, if we talk about the unit circle, let's draw out what we just wrote there. So we're in the xy plane. Oops. XY plane, and what's going to happen is if we have a radius of 1, then here I am at 1, here I am at 1, here I am at -1, and here I am at -1. Okay. In fact, I should say 1, 0. Here I am at 0, 1. And here I am at -1, 0. And here I am at 0, -1. Should be more proper, right? Now, the unit circle is just a circle that connects all these points, right? So we have a radius of 1. Oopsies. I wanted this flat. Okay. That circle was so good. Not a very nice circle, but that's okay. Okay. And so knowing these points is going to be really useful once we get into talking about angles and measurements and stuff like that. And so we've got these 4 check-in points on the unit circle, but we can actually check to see if other points are on the unit circle as well. So for example, just getting used to the unit circle and how it behaves. And so what I want you to do is show that the point P √3/3 and √6/3, oops, is on the unit circle. Okay. If that's true, right, then x is √3/3 and y is √6/3. Okay. So if that's true, then x² plus y² must be 1, right? So really what this is saying is that show that x² plus y² is equal to 1. Yeah. So we have the √3/3 squared, right? The square is on the outside, plus the √6/3 squared. Does it equal 1? So I'll put a little question mark. That doesn't really look like a question mark, does it? I'll put a question mark above because I'm not sure, and that's what I'm checking. Exponent laws, which we've worked at throughout the whole term, right, say I can bring in that square inside as long as I'm only multiplying or dividing inside, which is what I'm doing. So I can rewrite this as the √3, come on, √3 squared over 3 squared plus √6 squared over 3 squared. Does it equal 1? Okay. So √3 squared is just 3 divided by 3 squared, which is 9, plus 6. Same idea, right? √6 squared is 6 divided by 9, which is equal to 1 because 3 plus 6 is 9 over the common denominator of 9. 9 over 9 is equal to 1. Therefore, P, which was √3, oops, √3/3, √6/3 is on the unit circle. Okay. We can work the other way and we can find points on the unit circle. But before we do that, we need to kind of remind ourselves about the quadrants, which we haven't really talked about. Oh, maybe it's come up, I can't remember, but we'll definitely use it now in trig. So we will need to be familiar with the quadrants on the xy plane. With the quadrants on the xy plane. So if we have an xy plane like this, here's x, here's y, okay. Quadrants we denote by Roman numerals, so capital I is 1. Okay. Quadrant 1. Oh, maybe I'll write out 1. 2. Okay. 3. Oops. I say 3, but I wrote 4. 1, 2, 3. And finally, I don't know why I can't write these in the right order. 4. Okay, so notice that it's moving kind of this way, right? Oh, what have I done now, huh? How did that happen? I think, oh, there it is. I'm learning. So remember where the first quadrant is, and then you cycle through 1, 2, 3, 4, right? And what we need to remember is that, okay, in quadrant 1, x is positive and y is positive. Positive, positive. In quadrant 2, right, now we're on the negative x-axis, so x is going to be negative, and y is above the x-axis, so it's positive. In third quadrant, x is still negative and y is negative. So down here, we're going to have negative, negative. And then in the fourth quadrant, x is now positive, but the y is negative, right? So depending on which quadrant you're in is going to determine if your x's are positive or negative. Okay. So let's do another example or a different example. Okay, using this fact. The point P, which is at root 3 over 2 and y, is on the unit circle. In quadrant 4. In quadrant 4. Find its y coordinate. Okay. So here I want to solve for this y. I know it's on the unit circle, and I also know that I'm over here in the fourth quadrant. Okay. So being in the unit circle tells me what? Tells me that x squared plus y squared is 1. And knowing that it's in quadrant 4 tells me that x is positive, right? Which it is. Here, I'll clean up this root 3, right? It's equal to the root 3 over 2. But it also tells me that the y must be negative. And y must be negative, whatever it is, right? Whatever we find, it has to be a negative value. So we can use this information, right? So we kind of use this information to solve for y. All right, so we know that x squared plus y squared equals 1, okay? X is root 3 over 2. So what I'm going to do is I'm going to say root 3 over 2 squared plus y squared equals 1. Now I'm going to solve for y. What I'm going to do is I'm going to bring that square inside first. And so I get 3 over 2 squared, which is 4. Skipping a step. That's okay. We can make those little leaps. Plus y squared equals 1. So now if I subtract 3 over 4 from both sides, I'm left with y squared is 1 minus 3 over 4. In order to subtract these, right, I need to have a common denominator. And so I'll move this over a little bit. And I'll say times 4 over 4. Right? Or you can just think to yourself, you have to rewrite 1 as 4 over 4. That's fine. 1 times 4 is 4. So you haven't changed anything. But 4 minus 3 all over 4. So y squared is 4 minus 3 over 4. So y squared must be 1 over 4. Okay. Now, what's important, okay, especially now, is that when I take the square root of both sides, right, I have to take out the positive and the negative square root of 1 over 4. Okay? And so y squared is the plus minus root 1 over 4. Okay? This is going to be really important. Okay? Since negative 1 over, negative root 1 over 4 squared is 1 over 4. Okay? Because if you have a negative and you square it, it becomes the positive. And the positive, root 1 over 4 squared is also 1 over 4, right? So either way, to get from y squared to the root of 1 over 4 or 1 over 4, what happened? I kept my square on there, right? But to get from here is what I wanted to draw, right? From y squared equals 1 over 4. Well, if these are my y's, y's is plus minus root 1 over 4. Either way, if I square it, I get back to the 1 over 4. So that's why we have to have the plus minus. Okay. But we know from being in quadrant 4 that y must be negative, right? And so since y must be negative, since the point is in Q4, we know y must be negative. Okay. So y must be negative, negative root 1 over 4. I can bring that square root in, right? The square root is just the power of 1/2, right? So same idea. I can split this up and say negative root 1 over the root of 4, which is really just, y is the negative 1/2. Good. Okay. So the next thing we're going to talk about is terminal points. So of course this section is just kind of introducing a lot of terminology that we need to have a handle on, and just kind of how they relate. You'll notice that we're going quite slow, even though it probably doesn't feel like it to you. We're really kind of focusing on learning a lot of the stuff from the ground up. So a terminal point, okay. So terminal points on the unit circle. Oops. Terminal points on the unit circle. Oh, Suppose, and this is gonna take a little while to flesh out, and this is one of those things that I would usually just bring in and have pre-written for you guys, but I can't do that on here, so I probably can, but I haven't figured it out yet, so that's okay. Suppose t is a real number. that's just any number between negative infinity and infinity, right? And so we're just establishing that we can only talk about real numbers. Not really an issue for us, but it is something that in math we have to say. If t is greater than or equal to 0, we move a distance of t from the starting point of 1, 0. We move a distance of t along the unit circle, from the starting point 1, 0. Okay. And what I should say is we move a distance of t counterclockwise. So let me add that in. Counterclockwise. Oh, maybe not. Along the unit circle from the starting point 1, 0. So what that looks like is if you have your XY plane here and you have your unit circle, okay, then starting here at 1, 0, oops, I'm going to move to some point here, a distance of t counterclockwise if t is greater than 0. If it's equal to 0, I don't move from that point, right? So I'm talking about t greater than 0. I'll move counterclockwise. Okay? And so what you'll notice is that we'll always start at 1, 0. So we'll always start on the positive x-axis and move counterclockwise if our angle is positive, and clockwise if it's negative. Start on the positive x-axis. Okay. If t is less than 0, right, we move a distance of t clockwise along the unit circle from the starting point 1, 0. So the exact same thing, except the only thing that changes is that we're moving clockwise instead of counterclockwise. So if t is less than 0, okay, I do not want that. So if t is less than 0, we move a distance of, I'll do the absolute value of t, because if t is negative, the negative is just telling us to move clockwise, and then we just look at the distance of t. So don't be confused by that. It's probably just what you're thinking anyways. So the distance of absolute value of t, right, clockwise along the unit circle from the starting point 1, 0. So what does that look like? Draw my unit circle here. And so here I am at 1, 0. Let's say I moved that distance, right? Then t here, if t is less than 0, it just says I move a distance of t in the clockwise direction. So what we have here is we have a unit circle, and so if we're talking distances around this circle, right, then we're really talking about a portion of the circumference. Okay? And so since we are talking about distances, it is helpful to remember the circumference, which is the total distance around a circle. The circumference of any circle is c equals 2 pi r, right? And r equals 1 for the unit circle. So then the circumference is going to be 2 pi for the unit circle. Knowing that, we can split up the unit circle because we already know some of these points. So we can split up the circle into quarters. Okay. Knowing the total circumference is 2 pi, we can split the unit circle into quarters. We can split the unit circle into quarters and know the points that we'll call the terminal points. So know the points that each of these distances lands us on. So we can split this unit circle into quarters and know the points on the unit circle, corresponding to each quarter. To each quarter distance. Okay. We're later going to call this the terminal points. Okay. Actually, we already called it the terminal points, didn't we? T is the terminal point. But actually, no, let's not introduce that yet. It's not quite the terminal point. It's the distance that puts us at the terminal point. So, okay. All right. I guess how I had it was good. I just need to focus. All right. So what we have, right, if we know the total circumference is 2 pi, then, okay, what's better? I think if I draw just 4 quick little unit circles, that might be easier just for each quarter. So I might have something like 1, 2. I don't really need the 4th one, but I said I would do it, so 3, and get sloppier as I go. That's okay. So notice that we're always going to start here at 1, 0. 1, 0, 1, 0, 1, 0. And for a while we're developing all these things, we're going to work with positive angles, so positive values of t. And we know some key cutoff points, right? I know the point here is at 1, 0. I know the point on the next one is at -1. Sorry, this one's at 0, 1. X is 0, Y is 1. There, that's why it felt wrong. -1, 0. And then finally here, I'm at 0, -1. And then here I'll be back at 1, 0. Okay? So knowing that the total distance is 2 pi, I can figure out, and it might be easiest to go to the second one first, I can figure out that the distance from here to here must be just pi, 2 pi over 2. 2 pi over 2, which is just the distance of pi. Half of that is what we had over here, right? So this distance is going to be pi over 2. And then, of course, finally, moving from the first 1, 0 all the way 3 pi over 2 to the y-axis on the negative y-axis. And then finally here, we've moved a distance of 2 pi, which we're going to use later on, right? We can loop and loop and loop multiples of 2 pi. It'll just take us all around the circle. So, but we're saving that for a little bit later. So if we've moved a distance of pi over 2, pi, 3 pi over 2, or 2 pi, we know where we end up on the unit circle. Okay. So if we have moved a distance of pi over 2, pi, 3 pi over 2, or pi, oh sorry, or 2 pi, we know where we have ended up on the unit circle. We know where we have ended up on the unit circle. That's useful, right? Because that means I know my XY coordinates of that point. Okay. So let's just do some examples. So these points here, these points are called my terminal points. Okay. Terminal point. And maybe I should finish this sentence or add to this sentence. I know, sorry. So if we moved a distance of one of these 4, we know where we have ended up on the unit circle. That point is called the terminal point. Okay. Okay. So we're just going to do some practice. I feel like I wrote too hard on this thing. I write really hard because I have to grip so hard. But anyways, let's do an example. Finding terminal points. Find the terminal points. Find the terminal points on the unit circle determined by t. Determined by t. So for A, we're going to have t is 3 pi. Okay, that's weird, right? It's more than 2 pi, but that's okay. We can loop and loop and loop around the circle, and we still find a terminal point. B, t is going to be, actually, I'm going to write them across because that way I can just kind of do them underneath. t is going to be negative pi. Negative means I have to move in the clockwise direction, right? And c, let's do t is negative pi over 2. Okay, so again, paying attention to that negative, right? Negative pi over 2. Okie dokie. So for each of these, it's going to be really handy to just have a unit circle. So I'm just going to draw them out right away here. Okay. And again, they get uglier as I go. That's okay. All right. So what's going to happen is 3 pi, I'm just going to keep looping until I go and hit 3 pi. So I start here, of course, at 1, 0. And I know that if I move a distance of 2 pi, I get to there. So 2 pi, I need another pi. Another pi puts me halfway across again, right? And so here, oops. A distance of pi. And the terminal point here, remember, we're just staying on the unit circle. I'm not moving out or anything. I just want to show how often I go around. On the unit circle, that point on the negative x-axis is negative 1, 0. Okay. So the terminal point is at negative 1, 0. Okay. How about the next one? Okay, so now I'm moving in the negative direction, right? So this says I have to move clockwise. Clockwise a distance of pi. It actually doesn't matter. Pi clockwise or pi counterclockwise puts me in the same spot. But it's probably helpful if you just draw it out. So here, this is negative pi. This point is actually the same as the one we just found, negative 1, 0. So this is a terminal point at negative 1, 0. Notice that these have the same terminal point. Notice they have the same terminal point. Okay. Oops, terminal point. Okay. Later we'll call these coterminal, but I'm going to hold off on that for a little bit. So, well, maybe I'll put it on here. Coterminal. How about the third one? Okay, so I'm moving in the clockwise direction again because it's negative, and then pi over 2 is the distance. If we think about our default pi over 2 here, right, I know I've moved a quarter of the circle, but now I'm just moving a quarter of the circle in the clockwise direction. So from here, I'm moving negative pi over 2 to a point at x is 0 and y is negative 1. So the terminal point is 0, negative 1, which is different from the other two. So pretty useful to know, well, we don't see it quite yet. We haven't done anything to use these XY coordinates. But if I have an angle, right, which is what this t is going to turn into, right? So if I have something like one of these three, right, what I can translate them into is an XY coordinate. Okay, so what we're going to be wanting to do eventually is take an angle like this and translate it into an XY coordinate. Okay. Knowing these 4 check-in points is really good, really useful on the unit circle, but there are 3 other points that we need to just memorize and have available because they'll be just as useful. Okay. So knowing the 4 check-in points for t equals pi over 2, pi over 2 pi, 3 pi over 2, and 2 pi will be really useful later in finding XY coordinates, right? So we're going to use it to find x and y, xy, which is the terminal point. Okay. We're going to need a few more check-in points just along the way here, right? So we're not necessarily restricted to these quarter points, quarter waymarks, right? We're actually going to expand it to have 3 points in between each of these. Okay? What's nice though is we only need to remember the first quadrant, and then we'll be able to use it in the other 3 quadrants. Okay. There are 3 other check-in points for t, check-in points for t that we should memorize. Okay. Groovy. Okay. The first one is going to be at I'll just draw the unit circle and kind of go from there. How about that? Okay, let's see here. Here we're at 1, 0, and here we're at 0, 1. If we go halfway between these, okay, partway between, so here this was a distance of 0 and pi over 2, then halfway between those would be a distance of pi over 4, right? Halfway between them. So pi over 4 is another really useful check-in point that we need to have. Now, the terminal point for pi over 4 is not that obvious. The terminal point for t equals pi over 4, which is halfway between between 1, 0 and 0, 1 on the unit circle, is the point of, okay, root 2 over 2 and root 2 over 2. Okay. That's not that easy, right, to remember. but it's just one of those points that we need to remember, okay? So if you've moved a distance of pi over 4, you've ended up at x equals root 2 over 2 and y equals root 2 over 2. They are the same. Okay, which makes sense kind of if you think about, okay, I've moved halfway through a circle, my xy should be the same then because it's on this xy plane, but don't worry about that. Okay, just remember that if you have pi over 4 as your distance, then this is your terminal point. Okay. Another check-in point that we have is going to be pi over 6 and pi over 3. Okay. So let's see here. So this is the first one, let's say. And then actually, because I'm going to put them all on the same one now. Okay. So we've got, we already know at 1, 0 and 0, 1, and then we just established that when t is pi over 4, okay, then the point is at root 2 over 2, root 2 over 2. The other 2 points are kind of here and here. This is pi over 6, and this is pi over 3. Pi over 3 is at the point 1 over 2 and root 3 over 2. And pi over 6 is at the opposite, root 3 over 2 and 1 over 2. Okay. This is just a matter of memorizing. Okay. We can summarize this information in a table. This information in a table, which is going to be, okay, if t is 0, we know what it is. If it's pi over 6, then, okay, the terminal point at 0, it's 1, 0. Oops. At pi over 6, we just established, oh no, what happened here? So confusing. Okay. Back in action. So at pi over 6, we just established that we are at root 3 over 2, 1/2. At pi over 4, we said we were at root 2 over 2, root 2 over 2. And pi over 3, we were at the opposite of pi over 6, 1/2, oops, 1/2 root 3 over 2. Oh, and then let's do pi over 2, just for completeness, which is at 0, 1. Memorize one of these. They're the same, right? They have the same information. Whatever works for you, right? You have to memorize one of them. These check-in points, okay? So I actually find that this one is a little bit easier for me because I like having those visual points, but sometimes it's just easier to remember a table like this. So whatever you prefer, right? But you have to memorize these. There's no way around it. I'm sorry. But you are working kind of open book for your tests, right? So you can have it available, you can reference it, whichever way you prefer. Okay, but just notice that they are giving you the same information. So you only have to memorize one of these. Okay. So what we can do is we can use these reference angles to find terminal points. So for example, oh, there was something I wanted to, it'll come back up. I've forgotten it now. Find the terminal point determined by each t. Okay, so again, I'm going to do these kind of side by side. So first, a is going to be t is negative pi over 4. Okay. B, t is going to be 3 pi over 4. And C, t is going to be negative 5 pi over 6. Okay. So what I have to do is I have to remember the quadrants, right? Quadrant 1 is positive, positive, 2 is negative, positive, 3 is negative, negative, and 4 is positive, negative, right? So whichever quadrant I end up in, that's going to determine the positive or negative values of these numbers. So if I have something like this, I've got the unit circle here, and I've moved a distance of negative pi over 4. Well, pi over 4 is halfway through the circle. It doesn't matter which direction we're moving in. So negative pi over 4. Okay. Now I'm in the fourth quadrant, but what happens is that this is actually going to map to positive pi over 4. Okay, so notice here, oops, pi over 4, which we have memorized, not yet, but you will, is at the point root 2 over 2, oops, root 2 over 2 and root 2 over 2. Okay, so knowing that, okay, the x stays the same. Oops, I'll use a different color here. Root 2 over 2, because the x stays the same. X stays the same. But in the fourth quadrant, your y is negative, right? And so you're just going to make the negative of root 2 over 2. So you have negative root 2 over 2, because y is negative in the fourth quadrant. Okay. Good. Oh, so much for writing underneath here. No go. Oh. That's okay. We can do it down here. B, t is 3 pi over 4. So here, this is my terminal point, which is what I wanted. Therefore, the terminal point, I guess I should summarize, is at root 2 over 2, negative root 2 over 2. Same thing, 3 pi over 4, okay. 3 pi over 4. 4 pi over 4 would put me over here, right? At pi. But 3 pi over 4 is, wait. 3 pi over 4 puts me at, oh, come on. Here I've gone 2 pi over 4, right? Which is pi over 2. And then here I've got another pi over 4. So that's 3 pi over 4 in the positive direction. Okay. So this point here is going to be the same, right? If we just kind of map it across, it's going to be the same as pi over 4. So we use this kind of symmetry to map back and forth between the quadrants. Okay. So here, this point at 3 pi over 4, how can I write this? This point is going to be, so x becomes negative, right? So negative root 2 over 2, and y stays the same, so you're at root 2 over 2. So therefore, the terminal point determined by 3 pi over 4 is the point negative root 2 over 2, root 2 over 2. Okay. So, kind of the same idea, but we'll work on it a little bit more in C, negative 5 pi over 6. Negative 5 pi over 6, it's going to look something like, okay, negative puts me in this direction, right, the clockwise direction. So 6 pi over 6 would put me over here, right, on the negative x-axis. So I've moved almost all the way. In fact, I'm only 1/6 of the way to pi. So here, negative 5 pi over 6 puts us there. Okay, what we need to do is we do the same thing, but it's a little bit strange, right? Because what we have here is we have pi over 6. Okay, so what that means is that this is going to map through and put you at pi over 6 here. We're going to talk about this more, and they're called reference numbers. But for now, right, just kind of convince yourself that that's what's going on here. So if you've moved down pi over 6, then in the first quadrant, you've moved up pi over 6, right? And so the reference point or the terminal point for pi over 6, remember, is at, what was it, root 3 over 2? Yeah. Root 3 over 2, 1/2. Yeah. And so therefore, the terminal point determined by negative 5 pi over 6 is the point, okay? So my moving into the third quadrant, my x is negative and my y is negative, right? And so we have is negative root 3 over 2, negative 1/2. Both x and y are negative. Oops. In Q3. Okay. Good. So what we're using here is actually called a reference number. So what we used above is called a reference number. So a reference number is, and we'll just write out the definition, but it's just going to be the distance from the closest x-axis, right? So here in this example, right, it was the distance from the negative x-axis because that's the closest x-axis, right? And then we mapped it to that angle in the first quadrant. And so that's something that we're going to be able to do for all of these problems, is we're going to be able to find a reference number, map it to the first quadrant, and then make it positive or negative, whichever way we need it to be. So a reference number is, if we let t be a real number, that's any number between negative infinity and positive infinity, so it doesn't really mean much for us because we just assume that that's true, but in math we have to be really thorough, and so we're going to let it be a real number. Then the reference number t bar, okay, so here this should be a little bar on top, right? T bar associated, oops, associated with t, which is the original distance that you're traveling, is the shortest distance, along the unit circle, between the terminal point determined by t and the x-axis. So it's the shortest distance along the unit circle between the terminal point determined by t and the x-axis. Right, so that's why we say the closest x-axis. Okay. So really we're just defining the reference number. Okay. So what we're going to find is, depending on which quadrant we end up in, we're going to use a different reference number. So depending on the quadrant, our terminal point is in, depending on the quadrant, we will use different reference numbers. That's what I wanted to say. We will use different reference numbers. Okay, so for example, and I'm just going to have 4 unit circles here, 1 for each quadrant, right? So here, if I'm in Q1, here, if I'm in Q2, here I'll end up in Q3, and here I'll end up in Q4. Okay. So it doesn't actually matter where we end up in each of these quadrants. The reference number is going to be found the same way. Okay? So here, if I go a distance of, some distance of t, then t is going to be the same as my reference number t bar. Okay, so in Q1, they're the same, right? Because our reference numbers are going to map back to Q1, that makes sense. If I move to Q2, so somewhere in Q2, so here in blue is my t, then what's going to happen is that this distance is actually my t bar. So we're always going from the closest x-axis, and in Q2, our closest x-axis is the negative x-axis. So our reference number is actually going to be this distance here, right, from the negative x-axis to this point. There. Okay. If we're moving to Q3, the closest x-axis is still the negative x-axis, but we're moving down, right? And so if we move some distance here, then our reference angle is actually going to be, our reference number is going to be t bar, which is moving from, so here, from the negative x-axis down to that terminal point. Okay. T bar is always going to be positive. I'll make a note of it once we finish these examples, but that's always something to keep in mind, right? Is that this reference angle, even if we're moving clockwise or counterclockwise, it's always going to be positive because they'll be in the first quadrant. And so here, for ending up in the fourth quadrant, here we go, something like this maybe, okay? Oh, and I'll draw that line. So here's my t, and my reference number then is going to be the distance from the positive x-axis down to that terminal point. Okay. T bar will always be positive since it is mapping to Q1. Since it is mapping to quadrant 1. Okay. So let's do some examples here. Find the reference numbers. Find the reference number for each value of t. I'm going to try to put them side by side. That didn't work out last time, but I'll try it again. Let's see if we can do it. T is 5 pi over 6. Okay. B, hey. T is 7 pi over 4. Okay. There. Okay. C is negative 2 pi over 3. Okay, and I'll put that negative, I'll clean that up a little bit, move it closer. Okay, so for each of these, right, I'm going to move and find the terminal point, right, just like we were doing. And then now I'm going to add and find the reference number. Okay. Okie dokie. 5 pi over 6. So again, I feel like we've drawn some version of 5 pi over 6. 5 pi over 6, 6 pi over 6 would be at right on the negative x-axis. Oh, well. Right? So 5 pi over 6 is just pi over 6 away from a full pi. So my reference number would be pi over 6. So then t bar is pi over 6, and t would be my 5 pi over 6. Right. Let's do the next one. Seven pi over 4. Okay, so I'm going to break up this pi over 4 and say, okay, well, 8 pi over 4 would put me all the way around the circle. So I know I'm not quite at 8 pi over 4. 8 divided by 4 is 2, right? 2 pi. So what I'm going to do is to make it kind of easier for me to see is I'm going to go, okay, so if we're working in 4s, right? Okay. This distance would be 4 pi over 4, right? 4 pi over 4. I need another 3 pi over 4. 2 pi over 4 would be another, so here, 2 pi over 4, right? Plus that, and then I need another pi over 4. 4 pi over 4 plus 2 pi over 4 is 6 pi over 4 plus pi over 4 is 7 pi over 4. So the total here, so this is where I ended up, right? But what happens is it's really useful to know that the pi over 4 here is halfway, and so this must also be halfway, which is a distance of pi over 4 down from the positive x-axis. So t bar is pi over 4. Okay, so then here I'll say t is that. And then finally, if we have negative 2 pi over 3, so negative 2 pi over 3, okay, so I'm moving in the clockwise direction, and 2 over 3, if I split this into thirds, it might look something like, sure, like that. So I've gone 2/3 of the way, oops. Negative, so t equals negative 2 pi over 3. Okay. Which means that this distance, right, if I've gone 2 pi over 3, and to get back to here, this negative x-axis, then I need to move a distance of pi over 3. So t bar is pi over 3. So that's how you're going to find your reference angles. From your reference angles, you're going to be able to figure out what those terminal points are. Okay. But what I want to do is I just want to write out the instructions for finding these terminal points, and then we'll do some examples again. So using reference numbers, to find terminal points. Okay. to find the terminal point, P, usually a point, we call it P, capital Q, capital R. For some reason, we kind of stick to that portion of the alphabet. I don't know why, but that's how it is. It's not wrong to call a point capital A or something, but it's just not typical. To find the terminal point P, determined by any value of T, we use the following steps. Okay. So notice that these are the familiar angles that we know from quadrant 1, right? Pi over 6, pi over 4, pi over 3. So we're going to use that in finding the terminal points, right? We've already done a version of this. We're just highlighting it in steps now. 1, we have to find the reference number T bar. Okay. So that's what we were just doing. 2, find the terminal point determined by T bar. Okay, so find the terminal point. Find the terminal point, and we'll call it QAB, which is in quadrant 1. Determined by T bar. Determined by T bar. Okay, so you take your T bar, which is your reference number, you map it to Q1, and you know those points, right? You know the terminal points in Q1. And that's why we had to memorize those 3 core things, 3 core points. The terminal point determined by T is P plus minus A plus minus B, okay, where the signs are chosen according to the quadrant. Where the signs are chosen according to the quadrant. According to the quadrant in which this terminal point lies. In which this terminal point lies. Okay, so let's do an example before we wrap up here. Find the terminal point. Find the terminal point of T equals 5 pi over 6. 5 pi over 6 we just saw up here, right? So we already know the reference angle, or the reference number, I should say. So I'm just going to copy this out. Five pi over 6. T is 5 pi over 6. And T bar is 1 pi over 6. Pi over 6. So now what we do is we take this pi over 6 and say that in Q1, T equals pi over 6 is at the point And pi over 6, let's, I have to flip back. I don't have them memorized. Root 3 over 2 and 1/2, I think. It is. I'm well on my way. Root 3 over 2, 1/2. Okay. So that's how we're going to use it, right? So knowing pi over 6 and the point that corresponds to pi over 6, that's going to be really useful. But now we need to remember that, okay, in Q2, I know my x is negative and my y is positive. Okay. But since our point is in Q2, we know, oops, we know x is negative and y is positive. So the terminal point determined by t is 5 pi over 6 is, okay, x is negative root 3 over 2, and y is positive, which is just going to be 1/2. So that's how we're going to use these to figure out the terminal points all around the circle at these special cutoff points. We're not going to deal with anything but pi over 6, pi over 4, and pi over 3, right? So over 3, 4, 6, right? Those are the ones that we're going to deal with. All right, I think that's good for today. Are there any questions from either of you? Stop this recording.